technology, optimization processes, and different manufacturing sectors. He has published many international and national journals in his fields. So recently, he got one funded project from the Ministry of Mines, Government of India, around 74 lakhs. So with this, I invite you, sir. So you please start your presentation, sir.
Okay, sir. Thank you. Okay, am I audible and visible clearly?
Yes, yes.
Okay, so first of all, good evening to everyone, and I would like to thankful Dr. Asip Kumar and HOD Mechanical Engineering NMREC to give me this opportunity to what you can say as a speaker in this FDP program. And let me share the screen first. I have shared the screen. Is it visible to you? Just confirm me once.
No, sir.
It's not visible to you?
I think it is yet to come. It is showing presenting, maybe.
Okay, okay. Just wait then. I'm trying once more. Is it visible now?
Yes, sir.
Yes, yes, it is visible.
Okay, now it's visible, right?
Yes, yes.
Okay, so first of all, thanks again to organizer to give me this opportunity. So we'll start today's session, and the topic of the today's session is the advances in manufacturing techniques with industrial application. So basically, means all the participants here are MTech scholar, PhD scholar, as well as the many more faculty member also. So will not go through the theoretical part here, as because all of you know the theoretical means what you can say the concept among the 3D printing and all the manufacturing advanced manufacturing stuff. So basically today in this session we'll focus in the application of that particular thing. We'll not talk about any theoretical part. Okay, so better to start with this presentation. So about NIT Srinagar, let me introduce my what you can say institute. So this NIT Srinagar, it started in 1960 and has been one of the 18 regional engineering colleges established at that time. And the institute is situated at the banks of world famous Dal Lake with the far famed Hyderabad sign on the other side of this campus. So all of you might aware about this one ki the NIT Srinagar campus is very green and very beautiful. Behind the NIT Srinagar, one mountain is there, which is means almost 2 to 3 means covered with snow also. So here total 8 departments is there. Among that, I am belongs to mechanical engineering department. So here in our department, it is very what you can say, it's very unique thing that we have set up a in the tribology lab in which many scholars are working in the advancement of the what you can say the tribology and the material characterization. So basically my field is the welding and the cutting. I have done my research work in plasma cutting processes, although it is all of you know that key right now it's not strict about to that one field. Rather than we can explore many things also. So here we'll present a small what you can say the advancement of the in the manufacturing techniques in the field of 3D printing. Okay, so before going to that, we'll talk about some industrial revolution. As you know, there were earlier industry 1.0, 2.0, 3.0, and 4.0, but right now industry 5.0 have been introduced. And if you are going to the late 1800, earlier it was the mechanization, water and steam powers was there. That particular thing was invented at that time. And the industry 2.0 mass production, electric power assembly line was there. And in the third revolution, that way what we can say the computers, automated production and electronics early means introduced in the earlier 2000. Most of us know that key in 1990 or 95 around means we were aware about the computer system in our India. Then coming to the 4.0, the cyber physical system, IoT, networking, machine learning, the era of that in 2010. But right now in the industry 5.0, human robot collaboration, cognitive system customization. So right now what we are focusing like key the it's the what you can say it's the era for the computer science and IT because they are developing many more algorithm to what you can say the easy of daily human life. So better to what you can say the means the relation between the that mechanical part generally will consider about the robot and that customization will take care in this the industry 5.0. So these are some key points of the technology enablers of the industry 5.0 like industrial blockchain, then drone technology, then exoskeletons, additive technology, 5G beyond and mixed reality. Okay. So apart from this two things, basically we are focusing in drone technology in our mechanical engineering. Here in our NIT Srinagar, one drone technology lab has been introduced in our department and some research is going on regarding the what you can say the advancement of drone technology also. And additive manufacturing right now in India, everywhere and every institute will get this technology. And basically earlier it was what kind of focuses on the only plastic or any kind of ABS material was there. But right now we are moving towards the what you can say the metal additive technology. Coming to the 3D printing, what is 3D printing additive manufacturing means no need to describe a lot about this. Yeah, anyone? Okay, so means everybody knows that what is the 3D printing, what is the additive manufacturing, what is the advancement of this, what you can say the application, the advantages of the additive manufacturing. So we'll focus on the what you can say the application of the newly introduced additive manufacturing. Okay, so coming to this. What you can say the importance and the application of this additive manufacturing, we'll see there are some the little bit points are there like what is additive manufacturing or 3D printing, how is the technology being used and what are the challenges with 3D printing. That is the most and most important thing what you can say in the 3D printing industry. Like everybody is working towards the application and technology, but very less people are means bothered about the challenges. So most of the challenges is in the what you can say like suppose we are using the 3D printing in our what you can say the biomedical field, right? So there are so many challenges is there like the reaction of the material what we are using and the process which been used for the post-processing application. So as we know that in the post-processing application there are certain kinds of what you can say the chemical are being used to clean the surfaces. So sometimes some what you can say the reaction agent will be present there and that will be very harmful to the human body also. So we'll talk about this thing. So coming to the what you can say the what is additive manufacturing or 3D printing, all of you know that key it's a process by what you can say in means layer by layer manufacturing process, and several technologies are there to what you can say deposit the material layer upon layer. Okay, so we'll go some brief about that processes, and later on we'll switch to the specific application of the additive manufacturing, right? So here you can see some printed parts are there. Here it is shown here. Then coming to the classification based on the ASTM, which is American Society for Testing and Material. So here all the means what is the techniques for the theory the techniques for the additive manufacturing has been displayed here, and it is according to the less energy consumption to the more energy consumption. First of all, first one is your vat photopolymerization, material jetting, binder jetting, material extrusion, sheet lamination, powder bed fusion, and direct energy deposition. So everybody knows about the definition, the working principle about this one. So we will not take much more time about the theoretical part here. Like in the vat polymerization polymerization. So normally, whenever we are having a liquid material, or what you can say, the material is in the liquid form, generally use the wet photopolymerization, or the process in what you can say means. Consisting about this process is known as your stereolithography. In short form, we'll know that one as your SLA. Okay, so here a tank type will be there, and in this tank, the what you can say, the liquid resin will be there, and will direct the laser beam according to the layer. So means wherever the laser beam will directed, that particular part will be solidified. And whenever one layer has been manufactured, then we'll lower the table platform to unit thickness, or we can lift the what you can say the laser torch to 1 unit of thickness. Okay, so that depends on the process. Then coming to the material jetting. Same process is there here in the material jetting. A torch will be there, which will be consisting of metal, and you can say the example of the material jetting is your fused deposition modeling. And in this material jetting process, the generally we use the whirlpool of any ABS material, and in this torch itself, it is having the heating element, and that will melt to the molten metal and will deposit the material layer upon layer. In the binder jetting also same is there, means it is very similar to the material jetting. Only in the binder jetting, a binder will be released from the torch according to the layer. Okay, then metal extrusion is there. Then sheet lamination is there. In the sheet lamination, generally we use the sheet. Okay, and we'll cut that sheet through the laser according to the surface layer. Powder bed fusion means your SLS, selective laser sintering, and direct energy deposition means will directly deposited through that. So here in the means if you are taking consideration about the energy consumption, the DED is having most energy consumption process compared to the all other the processes. Okay, so these are the processes which is related to the 3D printing, like 3D CAD model, STL file, slicing software, then layer scenes and tool path, 3D printer, and 3D object. After that, if it is required, then we'll go for the post-processing. Okay, so these are some introduction to the technology. What you can say means it is basically it is showing in the pictorial form of this particular slides. Okay, and whatever the things is there, we already have discussed here, like material extrusion, then fused deposition modeling. You can see here the whirlpool is there, and what you can say basically we can compare this FDM model into our MIG welding process. Okay, where a what you can say whirlpool will be there of the filler material. Then material jetting is there, then binder jetting, then sheet lamination as we have discussed here, then wet polymerization or SLA techniques, then powder-based system SLS, and DED, as all of you have discussed. Okay, so here then we'll come to the application part of that specific technology or processes here. You can see here a full-scale mechanism prototype produced for Kaveri engine, which was commissioned used for HAL used in HAL Tejas aircraft. So this picture has taken from by one researchers in the HAL Bangalore, and you can see here this kind of engine, the prototype we can produce through the the 3D printing technology. So if you are comparing this 3D printing technology, then we can definitely, if someone will ask, sir, we can print this, we can manufacture the same using CNC or using any traditional machining process, then why we will switch to the 3D printing? What are the advantages of that? So means you can say if you are going for the large production, then only it will be feasible. Otherwise, suppose if you want to print 1 or 2 product, means it's very costly process, right? So if we'll go for some, you can see here, like here it is also described that 2,500 components needed for the assembly. 1 year estimated to machine part. CAD couldn't portray piping runs clearly. Then if we compare about the CNC, here you can see in the $60,000 via CNC with $20,000 with the FDM. In the suppose if we adopt the fused deposition modeling process, so it will means what you can say cheaper as compared to the CNC process. Okay, then lead time also reduced from 12 to 1.5. This is the actual data taken from the HAL Bangalore. Okay, so some students went to internship and they brought this data here. and here it is clearly means what you can say differentiate, but whenever we are asking about the mass production only, we can go for this one. Otherwise it will means what you can say cost more compared to the traditional machining process. So this is the picture they have taken, this one. Okay, then it's coming to some applications of the 3D printing process in the Center of Artificial Intelligence and Robotics. So here our in the robotics lab, all what you can say the students from the CSIT as well as the mechanical electronics people are working together, and means like the CSIT people, they don't know about much about the hardware like the movement and the mechanical parts of that particular robot or body what they are making for. So basically here in this picture you can see the all the body parts has been fabricated using 3D printing only. Okay, because if we go for the what is the suppose we are using the plastic metal, then the traditional process was your blow molding process. So in that process or the die casting process means this process is very useful because it's having many critical parts of the complex shape of the geometry. So better to go for this one if you are going for the mass production. So you can see here in the first picture the miniature unmanned ground vehicles is there. Means the prototype they has been fabricated here. It is used for tagged locomotion to the negotiate between rough terrain steps and the staircase, how it is moving there. So here the FDM body parts are the main body has been fabricated through the FDM process. Integrated sensors, electronics and battery mountings was there using this process. And the second one, the snake robot, the 14 segment of the alternate vertical and horizontal joints. So you can see here how many joints are there and how it is moving from moving in the floor also. So here the head and tail segment and the body parts has been fabricated using through this FDM technology. Okay, so in the third part, some what you can say the unmanned robot is shown here. So here also the white part, as you can see here, that this is the main body like integrated sensor, electronics and battery mountings has been fabricated using the FDM, and the consistent 15-degree angle for the ultrasonic sensor. And one more thing is there, if we'll go for the traditional process, if the parts complexity is then definitely will not get the accuracy. So here we can assure about the we can assure about the accuracy, because here the layer by layer printing is there, and suppose even 5-degree angle is there, we can easily fabricate. Okay, and in case of traditional machining process, first of all you have to make the pattern, and in that pattern, if any complex part is there or any small angle like 5-degree, 2-degree is there, then basically it's the very tough process to create a pattern. All of you know that. Okay, so here it is also showing the prototype of here the key application like tooling, composite tooling, sand casting, pattern, drill blocks, and in the rapid prototyping cases, the mechanism design and wind tunnel model is there. Okay, so this photo has been taken by ISRO. Okay, some student also went to their internship, and they have taken a photograph about whatever the prototype they have printed there. Okay, and these are some biomedical devices like anatomically medical devices, then what you can say the medical tooling. So right now all of we know that the biomedical devices or the biomaterials is the current research trend in our mechanical engineering, right? Like there is a huge research gap in the materials part, basically, which we can print through the 3D printing also. Okay, so we'll see. Actually, I have what you can say added some research part from the IIT Roorkee also. Once I visited to IIT Roorkee, and there is a very good research in the 3D printing in the medical application also. We'll see that here. Okay, so here one Altem company is there. So here you can see there are many things like the what you can say the inserts, then the devices, then the what you can say the small tissue engineering is also related to the 3D printing also. These are some parts they have fabricated. Okay, this data is taken from the Manipal Hospital, Bengaluru, where the scalp has been what you can say the scalp has been damaged, and they have printed some particular parts and they have adjusted. Okay, and this is about the footprint of that particular thing, and means if any fracture or any kind of heavy damage is there, then we can what you can say design according to our CAD model, and we can do the print and we can add in the body parts also. Okay, here also like some belts has been that what you can say that particular means gym equipment or that belt has also been fabricated using the additive manufacturing. Okay, so then coming to the next, the waste due to the wrong testing method, lack of organ transplant, and left to shelf time. These are the challenges while going for the 3D printing in the medical applications. Okay, and in this slide, it has been shown that the 3D bioprinting is a form of additive manufacturing that uses cells and other biocompatible materials as inks to print living structure layer by layer, which mimics the behavior of the natural living system. Okay, so this is for what you can say the research point of view. This is very important. Likewise, right now, many of the mechanical researchers have been what you can say working with the biomedical and the biotechnology researchers also, because they know means about the tissues, and we what you can say means integrate this tissue engineering with our 3D printing, right? Like cells, bioinks, culture media. These are the application of that tissue engineering. Okay, then these are some medical products like nose, ears. The what you can say the material first of all we'll have to select, and that is a very challenging task. Which kind of material will take, and is that will support to this or not, and will fabricate all these things according to that only. Okay, here we can see here some architectural engineering construction is there. Like suppose a high-rise building or skyscraper means have to develop from some construction company. So they may take they may take help of this additive manufacturing 3D printing also to make their model perfectly. You can see here in these parts how complexity is there, but still they are what you can say means they can understand all the complexity about from this figure or from this model. Okay, these are some what you can say the means advancement in 3D printing in the food industry also. Like some food item they can print also according to the means customer. It is the finally what you can say it is the completely customized thing. Okay, then some accessories like the shoes, so then some hair bands, and some what you can say ornaments also has been printed through the 3D printing processes. This is the design freedom, like daily use that stool, those which people are using for the sitting purposes also we can print like this. Means whatever we can design directly we can print layer by layer. So there is a nothing what you can say means limitations in the design part of view. These are some geometric freedom is there, like some drums and some equipments they have printed here. This is the low volume manufacturing. The mobile case also can be printed using this one, and this particular thing has been printed in our lab also in NIT Srinagar. Okay, and this is some 3D printing art is there. Okay, and some dress has been also designed using the 3D printing process, as you can see in this figure. Okay, then already I tell you this is the word brand, and this brand is generally using the 3D printing process for the earring, the necklaces, and many kinds of ornaments also. Okay, and here the what you can say the 3D printing technology they are using in the nail painting also. Okay, according to that they are means using the design and the layer by layer deposition techniques in the nail. Whatever the design someone will choose, then definitely it can be printed his or her nails. Okay, these are some statue already has been fabricated through the 3D printing, and most of you have been might have experience about this what you call the body parts of the this model of the someone. Okay, this is also fabricated using 3D printing. Okay, this is the house that has been printed in Chennai. All of you know that this is the one post office, I think, and this article has been released in the Times of India that using 3D printed techniques, the first 3D printed house has been set up in the Chennai city. And I think this, what you can say, that research has been done from IIT Madras. Okay, these are some newly developed tools. You can see here how the tools has been fabricated. This tool fabricated for water sprinkler and the forced air cool FSW process. As we are using the friction stir welding process, so here the heat generation is high, and to what you can say, the overcome that particular kind of heat energy, this sprinkler has been used, and this is fabricated through the 3D printing. Okay, so coming to this part here, you can see the, what you can say, the 3D printing here. One in the COVID times, the mask. Some people is having their pen in their ear, so this device has been fabricated to, what you can say, to relax the ear. Okay, then we'll go for the applications of additive manufacturing in the field of pharmaceuticals. Okay, so it is a very challenging task, and the research is, what you can say, the started, this research has been started here in our India also, but it is not so familiar and it will take much time. Like suppose if you see this graph here, you can see the application of 3D printing has been categorized under different sections. Like in the medical or dental means section, only 16.4% parts has been used, or parts has been fabricated through the 3D printing. Like consumer and products 21%, industrial business machine 13%, in academic institution for research only 6.8%, then government military 5.2%, architecture 3.9%, other 3.6%, automotive motor vehicle parts 18%, and aerospace 10%. So we can see here, means right now the trend is means going on in the medical or dental application, which is having 16%. So we'll see what are the reports are there in the upcoming slides. So here, suppose we'll take one example. If I will go for the 3D printing, and what is the basic means applications of that area in the additive manufacturing. Suppose we'll consider a product design here. Okay, so in this slide, you can see here two types of buckles is there. So basically this type of buckles has been used in the aircraft. Okay, so to tie the seat belt. Okay, so we'll compare the traditional design which all are available right now in our aircraft nowadays. Okay, and this is the additively manufactured optimized design for that particular thing. So in the first point, you can see here, a conventional steel buckle weighs 155 grams, suppose. Okay, and the titanium buckle designed with additive manufacturing weighs 70 gram. So basically the reduction is 155 gram to 70 gram, means basically it's around the 55%. Okay, so if we are means going through the data, means someone says, what is the big deal with this? If it was 155 gram earlier and right now it is 70 grams, so what is the means much more advancement? Only 55%, means only 155 gram to 70 grams. Then how much we will save? Nothing is there. Okay, but the data is saying that weight should be reduced on a like for the like basis within the saving project. And here for an Airbus 380 with all economy seating, suppose 853 seats are there. Okay, 853 seats are there. So just calculate the data here, like 853 multiplied by 155 for the traditional design, and for the optimized additively manufactured design, 853 into 70 grams. Okay, so in case of optimized design, it will around, I think, 72.5 kg, right? So in case of traditional design, the project partners are like Crucible Industrial Design, PRT. These are some company which means the company generally uses the techniques for the means a traditional design process. But here you can see over the airplane's lifetime, if we are considering about the aircraft lifetime, then 3.3 million liter of the fuel or approx, then you can say euro 2 million could be saved, assuming a saving of 45,000 liter per kg and airplane lifetime. So if we'll see the data like 155 gram and 70 gram, it's a very less one, right? 150 gram means less than what you can say a standard means weight of the mobile phone. Okay, so someone will think means what is the basic advantages or what is the applications to do this? Okay, but if we'll compare the total data, like means you can see here the 45,000 liter per kg. Okay, and what you can say, we can save like 3.3 million liter of fuel. So it's a very big data. Proceeding to the others one, like if we'll suppose means taking application of the pharma in the pharmacy industry. So here we'll what you can say discuss clearly about this, means how the application of additive manufacturing is there in the pharmacy industry. Like, okay, so suppose one tablet is there, right? 100 mg, right? So in what way we can understand this one? Okay, so suppose one person is there and he went to the doctor for the XYZ reason. Any problem was there, and he met a doctor, and doctor suggested him that you have to take 75 grams what you can say composition of this particular medicine. Okay, so most of all we know that 50 gram is available, 100 gram is available, 200 mg is available, milligram. Okay, but 75 milligram is not available. So in that case, doctor will suggest you break the tablet and you can take according to your requirement, right? And generally what happened to the other part, if we'll keep that other part for the upcoming time, then it may be harmful. So what generally people are doing, they're throwing that particular half part. Okay, so according to that means what you can say, again we'll take one more example according to the medicine manufacturing. Okay, so doctor has been suggested that first day you will take 100 mg, second day you will take 90 mg, third day you will take 80 mg, and subsequent to the 10 mg in the upcoming 10 days. Okay, so it's very challenging task to what you can say break the tablet according to that. Am I right? Suppose one tablet is there of the 100 mg, right? Then for 50 mg it is very easy. You can break from the center, and 25 mg also it is easy. You can what you can say the break from the quarter also. Okay, but if your body required 90 gram in the second day, then 80 milligram in the third day, it is very tough situation. So to tackle this kind of problem, generally what they are using, not using means it's introduced in the foreign country, but still it is a very what you can say research done in our India. Okay, means doctor what will do, he will keep all the raw materials for that one, means what you can say in the molten form of the medicines, and according to his prescription he will print the tablet in his lab or in his what you can say office or in his clinic, and he will pack according to that. And that particular medicine has been labeled like Monday, Tuesday, Wednesday, or day 1, day 2, day 3, right? So this is the what you can say distribution of the medicine. So in that case, in the second day, first day you can take one, second day also you can take one, but that particular medicine has been what you can say means weight as the 90 milligram as per your recommended the second day. Okay, so using this technique, what we can save, we can save the what you can say the wastage of the medicine, and we know how the cost of medicine are increasing day by day. Okay, so this is the healthcare provider you can see here, like 3D printed empowered compounding pharmacy. Means in this thing, why it is very challenging task in India, let me tell you. Like here, small, we are not what you can say in our India, 80% people are staying in the rural area or villages, and only 20% are staying in the urban area. So here in this technology, what we have to do, we have to equip all the hospitals or clinic with the lab, because without lab we cannot go for the printing of the medicine, right? So here in this picture you can see this the particular medicine is has been fabricated, and the first he need the full one. Okay, one guy is there, he need the full one. Then second one lady is there, she need the half one. And the third person, in this third number of person, he need the 2 tablet, and the fourth number of the lady, he need a capsule tablet. Okay, so it is the requirement of medicine vary from body to body. How? Because if the doctor will go undergo with some blood test or any kind of test, then he will suggest ki how much medicine required in your body. If same kind of composition required in every day, then nothing to worry about this one. Okay, if someone is saying that ki I need 100 mg first day also, second day also, third day, subsequent 10 days. Okay, so no need to worry about that, directly you can take. But as I gave example, like in the first day 100 mg is required, second day 90 mg is required, so it is very tough. Okay, and sometimes during means due to the overdose of medicines, many people is suffering some kind of means what you can say the health issue in their daily life. Okay, so medicine is a drugs, as we know. So if we are taking good means the required amount of quantity, means body will adapt easily. But if the overdose is medicine is there, it is very harmful. So you can see here need for the personalized medicine, the conventional fixed doses like average drug reaction. If else means saying about the drug reaction, means the means under what you can say the under composition or over composition. In England it is 2.3%, Germany 4.8, US 7.3, and India 2 to 3%. Low reporting. Okay, so means as we know, what you can say the immunity system of our Indian people is much more stronger compared to the US and England. Okay, so here means actually this is a theory only, but means to popularized in India, it is a very challenging task, because as you know, the means what you can say it depends on the geographical region. Okay, then like if you'll go to the Hyderabad, then it's mostly densely populated area. Okay, means if someone want, then they can set up their means clinic or the hospital, and they can distribute itself. Okay, but just think about Leh Ladakh or some rural part of Kashmir or some rural part of Himachal or Arunachal Pradesh. Okay, means as the population density is very less and they are having good immune system, then it won't means a big what you can say issues, right? So the personalized medicine is required those people wherever we need that one. Just like getting a new prescribed eyeglasses, like very helpful for the chronic disease like diabetes, cancer, then can be effective for the geriatric and pediatrics treatment also. So here, this the concept of the personalized medicine vary from body to body, vary from person to person, vary from region to region. Okay, if one developed country is there and the medicine overdose or the drug reaction is more than 20 or 30%, then definitely they will think about that, because it is very easy to implement in a what you can say the low volume people, means where the population the density is less and wherever the more population is less. Okay, so it's still what you can say a research part in all over our country, and basically one faculty is there in the IIT Roorkee. His name is Dr. Varun. Okay, he's working on this. Okay, so he thought this idea about that key, if we'll print the medicine according to the personalized, then it will be the saving of the medicine, and we can what you can say means prevent from the overdose reaction or the drug reaction. Okay, so you can see here the feasibility and environmental assessment. If you are taking about this one, then installation of AM machine is a costly affair. It's very costly machine, as we know. And what you can say means the challenging task is to keep the molten material, or here the molten material is our the liquid medicine, right? So it is a very challenging task to store there, right? Because the medicine, the packaging industry for the medicine is also very challenging task. Okay, so but the wider acceptance, the cost of the installation has decreased. The hardware cost of AM techniques have reduced drastically for about 51% from 2001 to 2010. Earlier it was much more costly, but right now every institute and every even small scale industry also they are using this particularly 3D printing process, right? So in 2016, FDA issued a certain draft guidelines to the regulated one, like first 3D printed drug approved by the FDA, then anti-seizing drugs, fast releasing force, and $55 for a strip of 6 tablets. You just think about that. Okay? Only 6 tablets cost $55. Okay, so if we convert the $55 into INR, it will be much more for only 6 tablets, right? So these are some what you can say company which they have what you can say they are means printing, or they are still in the research process. Like in the US, one company is there, in UK is there, in Mumbai one company is there, Vasta, TVA Estate, Vasta. Okay, they have also started this technology to print the machine, but not properly implemented due to this what you can say the costly affair, you can say. Okay, so if we are taking consideration about the environmental impact analysis, very few LC analysis of AM product due to lack of data. We don't have much data to means do the research also. So if we go for the personalized and sustainable approach of oral drug delivery system using additive manufacturing, in this figure, you just have a look here. In the first figure, the drug impregnation is there. Okay, where the raw PVA filament is there, means our medicine is in the form of the raw filament, which is like a whirlpool, and the ethanol chemical is there, and here absorbic acid drug, means everything. First of all, we have to mix and we have to make a molten what you can say the medicine. Okay, later on this techniques is connected with the tablet printing. So according to the doctor's prescription, the medicine has been printed here. Like as I told you, okay, if they will make a strip, okay, and in this strip having 5 or 6 tablets, so according to your day wise drug is will be printed according to that only. Like the first tablet will be 100 mg, second tablet will be 90 mg, third tablet will be 80 mg. So this kind of theory has been related to this one, and it will be printed according to that, and after that packing will be there. Okay, so this is the 3D printing tablet which has been printed in the IIT Roorkee in their lab itself. Okay, these are some data given by there. Like first the 3D model they have been using there, and after 3D printing, this is the picture you can see here. Okay, so some research, so what you can say, some scholars are also means doing research in this, like the infill percent, then infill style. Okay, then layer thickness, like 0.1, 0.2, 0.3, three kind of layer thickness they have been using. Then the infill style straight, octagon, round type of they are using. Then improvement percentage 0, 25, 35 are the variable. Okay, so for this particular medicine, the drug you can say this is the vitamin C, only vitamin C tablet they have printed for the reference only. Okay, the base metal was your PVA, and the printing temperature is your 190 degrees centigrade. Okay, so how they are printing this one, the preparation of drug loaded filament, like that as I told you, or in this slide you can see here, the raw PVA filament is there, and using the absorbic acid drug and the ethanol, they are using the molten form of the medicine. Okay, so here some data is shown here, like 50 mg of 50 milligram of the ascorbic acid powder, then 80 ml of the ethanol or water solvent, and they are mixing, and solution that will be the 15 gram of the PVN filament for 24-hour magnetic stirrer. One magnetic stirrer will be there that will be stirred to mix the medicine properly. Like, okay, so basically this is the still research data, so they have not shared much more about this one. Okay, so basically what you can say, this is what you can say, this is a personalized medicine. They has been printed according to the requirement of the particular body. So this kind of phenomena or this kind of theory we can bring for the researcher. Like we can go for the means the in the research part in the different domain. Okay, so this is only about the what you can say the demonstration of this one, and we don't have much more data about this one, how they have printed, and like means the body where they are means testing here. It's a very challenging task. So still the research is going on in this field. Okay, so thank you from my side, and these are some what you can say. I have tried a lot to show the applications of additive manufacturing in various industry like aerospace, then like medical, and like the pharmacy industry. Okay, so that's from my side, and now we'll start the question answer round or some suggestions from you. What kind of question is? I mean, it's basically it's a suggestion. Like if anyone is having any idea to means go beyond the research within the 3D printing, then definitely we can discuss about that one. Okay, Dr. Asit, that's from my side. Anyone can means interested to share their data or share their thoughts about the advancement of 3D printing, they may welcome.
Yes, thank you very much, Dr. Deepak, for such an insightful and enriching session. So we appreciate the way you have explained about different aspects of additive manufacturing. You have started the different types of additive manufacturing, starting from SLS, then you talked about FDM, you talked about the basic things of the additive manufacturing. And also you have discussed about how doctors are prescribing that medicine based on that patient requirement, how much mg he need to take. So that is also new thing we came to know, sir. So now we'll open the floor for the question. Dear participants, if you have any query or thoughts, please raise your hand or directly talk to Dr. Deepak.
Yeah, anyone can discuss about anything, like any idea is there or any advancement you know, or you came across in various industry or any institute, you can share your thoughts also.
Yes.
Hello, sir. Sir, good afternoon. Good evening. I'm Anuja from KT University.
Okay. Good evening,
sir.
Ma'am.
Yeah, good evening, sir. Sir, actually, my question is that the drug system, 3D printing of drugs, which you were telling just before, just recently, is some hospital is prescribing this, and if so, then are the doctors they are having, or the pathologist, means the medicine system, they have that system within in their chamber only, or what is the process of getting that customized medicine?
Okay, ma'am. Let me explain you one more thing. Like this is a only thought. Okay, this has not been what you can say means properly working in the market. Like as you know, in our country, how much difficulties is there. Like means suppose one hospital is there, and this hospital, the lab has to be equipped with the 3D printing machine or the tablet printing machine, right?
Yes.
So basically it's an idea only, means we cannot implement directly. As you know, our health system, okay, we are lacking a lot of things, right?
Yes.
So this technology has been taken from some what you can say some foreign country, means where the less people is there, and means suppose there is a town and only 4 to 5 hospitals is there, and all people are depending on that hospitals, right? So this kind of technology means they can use very easily, but we cannot use this kind of technology very easily, right? Because the first thing is that the doctor will prescribe you like the customized medicine the first day, the second day, the third day, right?
Yes.
And according to that, the lab staff shall be printing that particular type of medicine that will be given to the what you can say the patient. So it's a very challenging task. Means it's just a thought only. So if we want, then we can.
Sir, also my question is it practically possible? Because the 3D printing, it takes some time. So if the person has to take the medicine immediately, is it possible to means manufacture each and every day's dose according to the prescribed mg of the drugs?
Yes, ma'am. See, if the large scale production is going on, then definitely it will be very easy. Okay, but if means that machine is printing only 1 day 2-3 tablets, then after 10 days 2-3 tablets, then it is very tough, because the parameter setting for the machine is also important task,
yes,
or challenging task, right?
Yes, sir. Because what we have, I think what I have understood from the slide is for per person at each and every place, the according to weight and according to their little things, the dosage differs. So this is of course not a mass production. So I think that is again a great challenge to.
Obviously, that's why I told you it's a very great challenges. Okay, but it could done.
Professor Deepak.
Yes.
I have an insight in this Professor Anuja's question. In fact,
Sir.
we
Yes,
all
sir.
have
Welcome,
we all have a perception that tablets shall be with a certain size and the volume what we are expecting. But nowadays the medical field has emerged such that we are getting patches for the tablets. Even we can patch that. We can make a patch out of the medicine. Hardly in very minimal time that can be printed by the doctor to the patient. It is possible. There are different ways possibly that are existing in the medical field. That era is coming, in fact. But in fact, it was not proven completely, and it is not proven in the mass production, but it is happening, madam.
Sir, certainly it's a new concept I am hearing for the first time. Thank you so much for the insights. Thank you.
Actually, I also means last few months back ago, I went to a conference about the additive manufacturing, and one sir, he's from IT Roorkee, and he came and he only means presented this kind of data. So we all got shocked. This kind of thing we means haven't heard earlier. Okay, because means he told that like suppose let us take an example, means levocetirizine and hydrochloric acid, some tablet is there. Okay, so some people need the levocetirizine, some people need the hydrochloric machine. Okay, so means individual there is not available. So if we'll go for the customized printing, then we can print any variation of that medicine. Like if the particular thing is required, then they can do it. But again I told you that it is very challenging task for our country. Because
Yes,
if there is a country, they are having population maximum 5 lakh or 7 lakh or 10 lakhs people, okay, and they are having hospitals total, I think 500 or 1000, okay, so they can implement that machine in their lab, because for this particular thing, the lab will be very much equipped and will be integrated with the clinic also, the prescribed doctor also. So after suppose doctor is prescribing something, and the lab staff, they can print directly and they can give to the patient. Okay, this is for the ease of use only. As I told you, suppose you need the 50 mg, then directly we can break the medicine if 100 mg is there. But if it is the customized for the daily basis, then it is very tough. So this is the idea only. So those who are doing research in the additive manufacturing, the biomaterials, or that pharmaceutical industry, they can adopt this one for their further research. How this process can be easy to implement in our country. I don't think so. In a single hospital in our country, this process has been introduced. That's my knowledge.
Yes, sir. Again, last question.
One more point to be added for this, madam. In fact, the major hurdle in this medicine field is that usually a patient requires a certain dosage of combination medicine. The combinations are not directly available in the market because they cannot produce, they cannot do the job order production from pharma, since they are going to supply the medication such that it is 0.1 and 400 mg combination if they're going to produce, but patients require 0.2 and about like 300 mg. That is not available, so that doctor has to adjust the dose and has to prescribe it. That is the challenge. In that scenario, this concept of additive manufacturing, wherein it is not, we all have a perception that we all presume that additive manufacturing, wherein the heated nozzle from which nozzle filament comes out. But in fact, there is a concept of 3D building concept, wherein the nozzle will be present. There is no heated nozzle will be present. The binding agent will come and will add it to so that it will be added and part will be fabricated. In the similar lines, drug manufacturing also there is a possible, and it is an advancement in the medical field, so that as sir said, day-to-day medication, the reducing dose is very important. See, the entire duration of the fever, the patient cannot take 650 mg of paracetamol continuously. The dosage
Yes,
will be
yes.
reduced, and accordingly the fever comes down, and he cannot immediately stop also. The adverse effect need to be considered with the advancement of technology, in my knowledge. Thank you very much.
Thank you so much, sir. Sir, my last question is the tool, new additive manufacturing tool with coolant, which you just shown in the slide, that is present in some IIT, right?
Yes, that is not my work. This data
No, no.
all has been collected from our internship team.
Yeah, so I just wanted to know, is open research allowed there for that tools things? Means if someone want to go for a research, will they allow outside?
I think through proper channel it will be possible.
Okay, sir.
Okay,
Thank you.
individual I don't think so, but through proper channel, like suppose you are from KIT University, right? If
Right, sir.
the director or the head of the department suggested, and the forwarded letter means they may allow. That is not a big issue, because in point of research part of view, no one will be denied, right?
Thank you so much, sir. Thank you.
Thank you, ma'am.
Sir, good evening, sir. Deepak, sir.
Good evening, sir.
Is my voice audible, sir?
Yes, it was audible. Please.
Sir, I want to know, is there any setup with you regarding the tribological studies with at elevated temperatures?
Elevated temperature, that we'll have to check, sir. Actually, I'm not the in charge of tribology lab, but they are having a very good setup here. After you can see, you can say like after IIT Delhi and IIT Srinagar is having very good what you can establish tribology lab.
Yes, I know that, sir. That's
So
why
if you are having any issues or you want anything, just mail me and I will check it here and I will reply back to you. Okay.
Okay, sir. Any additive manufacturing facilities available with you? Like
yes, one FDM printing machine is there. It is a very good machine, but right now it is means what you can say the under maintenance only. The machine has been break down already.
Okay. Metal additive manufacturing, sir?
No, we are having that in IIT Jammu. Actually, some of my scholars are also working in this metal additive manufacturing. So that particular setup has been done through IIT Jammu, and our student also means going there and they are doing their research in IIT Jammu also. That particularly that fabrication part.
Okay. Okay.
So, anyone is there?
Participants who are having much time, you can ask your query to the speaker.
Sir, 1 minute. Means those who are having any proposal or any kind of queries, you can please email me, and my mail ID is deepak.kumar@nitc.ac.in. This is my official email ID of NITC Nagar. So you may mail in that ID. Okay.
Sir, there is one question in the chat box. Rajesh Sriala is asking, will preheating of the powder before the printing will increase the bonding or improve the tensile strength?
Tensile strength is the different aspect, right? Like if you need, then some preheating process is there. What is the use of preheating in the additive manufacturing? Basically, in the powder bed fusion, if we are going for the preheating, then means it will act like a bonding agent. Means what you can say the natural adhesive also. Okay, so tensile strength you are saying about, suppose you are fabricating some plastic or some ABS. Okay, so we cannot much expect the tensile strength, right? If you are going for the what you can say the metal additive manufacturing, then in this case we can go for the tensile strength study. And definitely the tensile strength of this additively manufactured part will be very much good as compared to the traditional process. And one more thing is there, basically we are going the 3D printing process for if the parts is having more complex. And suppose a normal part is there, suppose like a brick is there after a rectangle shape. Okay, so directly we can go for the casting process or any other process. If any complexity is there, then only we can go for this one. And in case of mass production.
Sir, one general question. Long back in the years of about like 2000, 2011, 12, 13, 14, there is a significant research contributed by all the researchers in the form of composite materials. Something like, hand laying method by using rice or different materials. The tests were carried out and research was published. Now, is it possible that the handling techniques can be adopted with, in combination with the 3D printed parts, such as like one layer of 3D printing, and after that adhesive and other layer of the composite material, the material to be composited, and another layer of 3D printed part with the thickness of as specified in the previous established research. And the tests were carried out, or any other? Is there any research going on in the area of in the similar lines?
Sir, that we have to check. Like many researchers are doing their research according to their application. Like, first of all, if someone is starting some research work, then first of all, the research gap they need to identify. If they require this particular type of that you told us, that adhesive bonding between the two layer. If it is required, then we can do for that one. And after that, we have to check all the what you can say the mechanical properties of that particular fabricated part. And after that only we came to know that whether that process is adaptable or not. There is a good question. Okay, you should proceed about that research work.
Thank you. Thank you very much.
Yes.
So any other query from participants? I have one question, Dr. Deepak.
Yes, sir.
One basic, actually, you talked about the additive manufacturing or 3D printing. So that is the one way of making any product smarter. As our topic is smart and sustainability manufacturing. So by using this 3D printing, we can do the smart manufacturing. How can we integrate this?
You are asking means how it is relatable?
Yes, how we can integrate this sustainability aspect in 3D printing.
Okay, so as all of you know that there is a one more advancement process here, that is the 4D printing, right? So what is that 4D printing? Again, means as we know that 2D printing is two-dimensional, 3D printing is three-dimensional. Then what comes the theory about the 4D printing? First of all, when I heard also, I got shocked. What is that 4D printing? Is there any, means 4 dimension is also there? Okay, so as you told that sustainable manufacturing, so let me explain one some points about that one. Like as you know, the Kashmir is means a negative temperature zone in the winter. Okay, so what you can say, the most of the means period of the late December to the early January or the late January, means due to the subsequent sub-zero temperature, the pipes getting freezes due to the ice. Okay, there is a very much people are facing issues or trouble in the water supply because the pipes are freezing. So what is the 4D means 4D printing means the material should be smart enough to changes its shape and size according to the environmental stimuli. Means suppose a temperature range is there 30 degree, same material will be work in the 30 degree, and suppose a temperature range of -10 to -20 degree. So that particular material cannot survive in the 30, 70 degree, 80 degree or -10 or -20 degree. So the what you can say, the smart material they are using now in the 3D printing process. So you can print a particular type, but according to the environmental stimuli, there are so many factors. So according to that particular product can change the shape and size according to the different factors. Okay, so in this way we can relate the 3D advances in 3D printing in case of your sustainable manufacturing. Like a different season, we do not require differences in the different product. If we are printing one product using this 4D printing technology, then it will work throughout the year. Or throughout means if you are saying about the temperature, as I gave one what you can say example of that one. If you are taking if you are taking example about the pressure, then suppose normal atmospheric pressure is there in your Hyderabad region, and some atmospheric pressure is there in Kashmir and in the Leh Ladakh, that is a high altitude. Okay, and if you are testing the same product beyond or beneath the sea level or water level, means the pressure difference is different at each and every places. Okay, so that particular product what we are printing, if that is okay with all the environment or all the pressure variations, then we can say that is a sustainable manufacturing only.
Okay, sir. Thank you, sir. Any query from participants, or else we'll end this session? Any query from participants? Okay, if not query,
I think, sir, you can conclude.
Yes, sir.
The session.
So once again, thank you, Dr. Deepak, for your valuable
Thank
time,
you, sir.
and
Thank you, sir.
for delivering such a wonderful and insightful session. So on behalf of our organizing committee and from all participants, we extend our gratitude for sharing your expertise and your experience with us. So we are sure the knowledge gained by today will benefit to all participants, to all my faculty. So once again, thank you. So with this, we are concluding this session. So dear participants, do not leave this meeting. So we'll have another session at 7:30. So we can take a 10-minute break, then we can join around 7:30. So those have not filled that Google form, please fill this Google form. So because it is time limit bound, try to fill this form as early as possible. So thank you, Deepak, once again.
Thank you, sir. Thank you for giving the opportunity for this FDP. May I know the name of your HOD, mechanical HOD?
Yes, our HOD, Dr. TBS MR Bhusan, he is also working with this area.
Okay.
This 3D printing area. Sir is, I think, sir is online.
Yes, good evening, sir. I'm Dr. Bhushan.
Yeah.
Yeah.
Yes, sir. Good evening.
Thank you very much for your.
So definitely we'll be touch, sir. We'll be in the touch,
sure.
and we'll start any kind of collaborative work is there.
Yeah,
Okay.
we'll collaborate
Definitely
in the
I will
research,
inform.
and we'll do some sort of work and publications also. And there is one other faculty member who is working in the area of tribology in our department, so that we can have a good association and we can work together. I'm looking forward to
Yes, sir. Yes, sir. Sure.
Thank you very much, sir.
Okay, welcome, sir. Thanks a lot. So shall I leave, sir? Rashid, sir, may I leave now?
Yes, sir. Please, sir. We'll talk, sir.
Okay. Okay, sir.
Thank you.
Thank you all.
Okay. So we'll take 10 to 15 minute break. Then we can join around 7:30.